Hey everyone, Craig here, and today we're going to be looking at FreeNAS. So FreeNAS is the tool that we've chosen to be our storage provider for our new lab. FreeNAS is, I'm not going to go into too much detail about it. It's a really cool storage product. It's a piece of software that you install onto a server, and it gives you a bunch of mechanisms to connect things and servers and all sorts of bits. There's SMB if you prefer using Windows shares. There's NFS. There's AFP for Apple. There's iSCSI for your block storage. So it's quite a versatile tool. It's based around ZFS. So ZFS is a file system. It's quite particular about what it wants. It wants direct access to your hardware, to your disks, because it wants to be able to see if there's any failures come in. It wants to know the smart information about your disks, all that kind of stuff. ZFS doesn't get on very well at all with any kind of caching RAID controllers, so it's going to be interesting to see how this actually performs and how it behaves on this box. The server that we're installing this to is a HP ProLine 380, and it's got a P420 card in it. Now this P420 card is really good, but you can't put it into just a bunch of disk mode and just present it through to ZFS. So that's going to pose some challenges for us. This box here. So first thing we're going to do is we're going to just download FreeNAS. Now I've got to admit I've cheated. I've already downloaded it, but once you hit the download button, you're going to be presented with this form to ask you to register for the newsletter. I probably would if I were you, if anything, just so that if there's any vulnerability alerts or anything like that come out, you'll get them from this. But if you don't want to sign up, that's absolutely fine. Just hit this no thank you, take me to the download page please, which will take you here. And then we know that we're going to get FreeNAS 11.2 U6, which at the time of release, right now, this is the latest version of this tool. So just hit download and you'll get the ISO. I'm not going to do that. I've already downloaded it. So the next thing we're going to be doing in order to prepare the hardware for FreeNAS is we're going to go and configure the disks. So this server itself has 20 WD Blue SSDs. Again, nothing fancy. There's just a lot of them. And it's got 5 bits of spinny WD Rust. And what we need to do with them is configure them into a bunch of RAID 0 arrays with a single disk in. And the reason why we do that is because we can't just pass through a single, a bunch of disks. We need to give ZFS something it can work with. And if you start, because ZFS is a RAID type system, if you start putting ZFS on top of hardware rated disk arrays, you're not going to have a very good time. It's not going to be very pleasant for you. So in order to deal with that, we're using RAID 0. So I did have to do a couple of bits before getting here, but I'm not going to cover them in this video. Just around, upgrading firmware on the storage controller itself and installing Java on this machine and stuff like that. Nothing that's really that interesting. But the first thing I'm going to do is I'm going to mount an ISO here with the HP service pack. Now I've covered in another video how to deal with updating the firmware and all that kind of stuff for the storage card, so we're not going to do that today. But the reason why I'm using the service pack to access to configure the disks here is that there's a really useful feature that you can just click a button and it will provision all of your disks as a RAID 0 set of disks, which is really handy, especially for something like this. And it also turns out that once you configure your box using the later version of the array configuration utility, you can't use the old one again. Certainly not for the same arrays. So it just means that you're perpetually going to have this service pack around. Okay, right. So now all we can do is we'll go through the EULA, and we're going to go to Smart Storage Administrator. So this is the disk configuration utility, and this is what we're going to use to interact with the disks. As I said, I used this newer version to configure them already. Well, I just wanted to show you kind of what it looks like and how it works. I've got to say it's a lot nicer than the one that's already on there. Okay, so we can see here we've got 25 disks. It's saying it was 21 SSDs. Now that's not right. I don't know where it's getting 21 from, unless it's counting the NVMe. Oh wow, it is. It's counting the NVMe as well. I'm genuinely surprised at seeing that. That's quite clever. So this server also, apart from the 20 SSDs from WD and the 5 spinny bits of Rust, I've got an NVMe disk in here, which I was going to save as a bit of either a super fast data store, or I was going to use it as a caching tier for the slower disks. I don't really think there's any benefit of using it for the SSDs. I don't think I'll see any improvement at all. Certainly not for the type of workload that I'm going to be doing. Maybe if we start using NFS as the data store, it might be worthwhile, certainly for sequential writes. But anyway, so we've got all of these disks configured. They're all configured as, where are we? If we go to configure, where's I'm trying to show you the button. So there's a button that appears here. I've got it in the other video anyway. I'll link to that. Which kind of sets, all right, yeah, go off and do that. Just do all the configuration as a single disk RAID 0 logical array for every device in the server, and you literally just say, you click the groups of devices you want, and away it goes. So there's the 5 WDs. They're not massively fast. They're 5K disks, but you know what? It's perfect for what I want. They're all 5 terabyte disks as well, which is good. Okay, so we've got, we can see here that we've got some errors, some little warnings. I'm not worried about that at all. It's purely because these things are in they're in caddies that aren't the Gen 8 caddies, so they look to be unofficial. Well, they are unofficial as far as HP is concerned. Don't know what this is. Cool. No idea what that is. Anyway, okay, so our disks are configured. We can see we've got 25 logical devices. If I go into one of them, we can tell that it's a single disk, so it's RAID 0. We can see that there's caching per disk, and if we look at what the defaults are, I think it's a few meg or something. Yeah. So this is write caching, and there's read caching as well, but actually, do I care about read caching? We can only enable it for these disks anyway, so I'm going to leave it as it is, because I don't think the reads are going to be massively slow. The SSDs are not going to benefit at all from that, so we'll just leave it as it is. Okay, so next what I'm going to do is I'm going to go ahead and mount the FreeNAS ISO. So this is where we start getting to the good bit. I'm just going to go ahead and do a fresh reset on that, and next thing we know, we're going to be in the installer. Okay, so the installer's loading now. It's booting up from the ISO that we've already attached here. We'll see that FreeNAS is going to pick up a load of disks. Now, it's worth calling out, I already had FreeNAS on this box, so we're going to do a clean install to a USB stick that's located on the inside of the ProLiant. These ProLiants all have both a compact flash and a USB port internally. I'm using a USB port, but I'm kind of thinking maybe a compact flash card would have been a bit more resilient. Never mind. Anyway, so hitting enter. And hopefully this is going to go ahead and do the boot for me into the installer. Excellent. Right, so we've got the installer. So what we're going to do is we're going to just run into the install and see what happens. So if we choose the destination, so I don't want it on any of these. Right here we are. We're going to stick it on this. SanDisk Cruiser. So it's only a 16 gig disk drive. It doesn't need to be huge. It will do what it says on the tin for us. So we'll select that. We'll hit with space. We'll hit enter. There we go. Now it's asking us, because we've already got a version of FreeNAS on there, do we want to do a fresh install or do we want to upgrade? We're going to do a fresh install. And we're going to format the boot device because I don't want anything to be left. And I'm going to set my device password. There we go. We're going to boot via BIOS because this server doesn't support UEFI. So we'll choose BIOS mode. And there we go. That's the installation completed. That was really easy. It took maybe, I don't know, 5-10 minutes, something like that to get through. The next step for us is to reboot the box. So if I go ahead and just hit enter there, we'll go down to reboot. While it's rebooting, I'm going to, just when the screen goes black, I'm going to take the DVD out, or the CD-ROM out, just so it doesn't try to boot from the installer again. There we go, 10 minutes it took us to get through that. Okay, so I'll unplug the CD drive. So we've installed this onto one of these things. I don't know if you can see that very well, but this is a SanDisk Cruiser. It's a 64 gig version of the same USB stick, and it's literally USB 2. These things are pretty resilient. I've used quite a few different types of USB sticks, and these are the ones that I've had the most success with. They seem to be the most reliable. Of course, you get some bad batches, but you do with anything. But these are my go-to sticks of choice. They're only USB 2, but I don't really see a need to use USB 3. I mean, all that's happening here is something's being booted from, and then it's going into RAM. And once it's in RAM, it doesn't really matter anymore. It's nice and fast. Yeah, I mean, from everything I've kind of heard, again, none of this is by any means scientific, but everything I've heard, the USB 3 discs tend to fail a bit quicker, especially if you're leaving them plugged in, switched on all the time, with continuous write cycles to them. So yeah, nice bits of kit. Okay, so here we go, booting from the USB stick. I've already configured the BIOS to boot from USB. So if you come to do this yourself, just make sure that you've got the boot order right and that your box will boot from USB. These ProLiants, if you've got two actual USB sticks in them, and then you come to use the USB mounted, you put in a CD or something from the console here, you might have some problems. I've had some issues where if you've got 3 USB devices to boot from, it's not very happy. It doesn't necessarily behave how you want it to and boot correctly. So just bear that in mind. Hey, excellent. And there we have it. So now we have, we've got a booted FreeNAS box. So let's go and have a look at what that is actually doing. Right then. Okay, so FreeNAS. So if I stick in my credentials, ta-da, we have a freshly minted FreeNAS box. And so as you can see, it's quite a nice interface actually. We've got network configuration here, so all your interfaces get configured as part of this. A little bit surprised we don't have interface configuration there already, but you can see the two 10 gig ports and then the 4 1 gig ports. And as for storage, over here no pools, but that's fine because we haven't created any. But what we can see is all of the disks. So these are all of the disks that we've got here. 25 DA25 here being our USB disk, which we've just booted from. Excellent. Okay, so I'm going to pause and grab a drink, and then we'll be back to configure this thing. Okay, let's configure this thing. So first thing we're going to look at is we're going to go into the system, and we're just going to give it a proper time zone. So because this is a server, I'm going to configure it as UTC. I don't particularly, I'm going to leave the syslog level as that. I haven't got a syslog server set up yet, but this is on my list of things to do. I'm also going to set up HTTP and HTTPS configuration, I think. Actually, no, I'm not, because I haven't got a cert that I can use. So I'm going to leave that as it is and just save that. It's going to want to restart, so we'll say yes, that's fine. Obviously, it's better practice to have things like this encrypted, but we'll come back to that. That's not too big of a deal. Right, time. So time is important. Time is properly configured by the looks of it. There's a couple of NTP servers configured. That looks fine to me. Advanced. Anything we want to tweak in here? No, I don't think so. Email. I'm not going to configure any of this just now. Obviously, if you want to get alerts from your system if there's any kind of errors or anything, this is the place to configure that. System dataset can stay as is. So the system dataset is quite good because if you wanted to put your logs somewhere, it's effectively just your /var and what's that? Yeah, I think this is /var as well. Otherwise, it will get stored in memory. But so it's a good idea to select something to persistently store this stuff to. You don't want to be storing it on FreeNAS boot because this is a USB disk, and if you do that, you're going to be in for a bad time. Your box is probably going to flake out at some point. Okay, so alerts, settings, and services. We'll leave those as they are for now. Again, when we start getting things set up a bit more, we're going to want alerts coming from this box, just so it's properly monitored. We don't care about any tunables or anything like that for now. Tell you what, let's check to see if there's any updates. Yeah, no new updates on this update train. So FreeNAS updates are delivered in these kind of trains, so you can choose nightlies if you really like pain. If you like even more pain, you could probably go for the SDK. I'm going to stick on the release, the stable train here, just because I like my storage to work. Certs, we've got nothing there. Okay, so let's look at network. So networking, we should be able to configure our hostname. There it is. So I'm going to call this freenas01.mgt.uk.eti.io. And I realize I've probably put it the wrong way around. So actually this should be that. Oops, more like this. There we go. Default gateway, we'll leave all this stuff as it is for now, as it's all picked up anyway by DHCP, so I'm quite happy with that. There we go. Okay, so the weird thing we're seeing here in the interfaces section is there's no interfaces configured. That's kind of a problem. I was expecting to see some stuff here. I mean, if we look at the network summary, we've got this kind of configuration. So I think what we're going to do first is we're going to configure the management interface first, this IGB0, and then we're going to connect to this. So at the moment, we're connected on one of the 10 gig interfaces. So if we configure this, so I'll just copy that IP address because I want to keep it. And because it's a management interface, there's no VLAN. I don't use a VLAN for this. And we're going to call this IGB0. Yeah, that's fine. I don't care about that. IP address. We'll leave it as DHCP. No, we won't. We'll just not take this for chance. We'll leave that as that. And we're gonna, what's this? This is a /23 network. No IPv6. I don't care about IPv6. We don't have any additional addresses either, so we'll leave that as it is for now. No aliases. So if we hit this, Yeah, okay, so this isn't looking too clever, and that's probably because I've just made a big mistake configuring this, but never mind. What we can do is recover from that, and so we'll recover by going into ILO. Again, one of the benefits of having remote management is if you really cock something up, you can go back and fix it. So I'm just going to go ahead and get my credentials from my notes. There it is. There we go. Okay, so if we launch the HTML5 client here, and let's see what's going on. Okay, so it should be accessible from this 50.10.17 address that we've just configured. So that's on interface 3. So let's go and have a look. We don't want to delete it. We don't want to delete the current settings. We don't want to configure by DHCP. But we do want to configure IPv4. So the interface name is going to stay that. We're going to keep... what are we going to do? We're going to configure this as 10.50.10.17/23. We don't want to configure IPv6, so that should restart that. I think what we didn't do was configure the default route, so let's configure that. So the default route is going to be to 10.50.10.1, and we don't have an IPv6 default route, so that's that. And if we go back over to 10, there we go. Okay, so now it's happy. So if I log in again, see, it pays to read the instructions, folks. Okay, so if we start now, now we've got the management interface configured here, what we can start, and by the way, it's always worthwhile with this type of thing to configure a static IP address because you don't want your storage server going away. Typically for servers, I very rarely configure DHCP. I used to, and then I was bitten by it. My DHCP server went away and leases got messed up and bad times were had. Generally, especially in a production environment, DHCP is good. Depending what your network's doing, you probably shouldn't have DHCP. If it's kind of a build network, or you're only using DHCP to kind of bootstrap part of a process or something like that, or it's some kind of access network with transient clients, that's absolutely fine. But I wouldn't use DHCP for server-based networks, just because you're going to end up having a bad time. It's always better to have something kind of cataloging IP addresses centrally, and reserving them, and then allocating them statically. Saves so many headaches that way. Anyway, so if we now take a look at our two 10 gig interfaces, now so if we look at the network summary, we can see that the 10 gig interfaces have disappeared. Actually, so is our name server configuration. So let's configure that real quick. So I know that our name servers are configured here, and we've actually only got one of them. So I'm going to go ahead and plumb that in. Okay, so storage wise, the actual thing that we're going to be doing with this box, we're going to want to have two interfaces. So we're going to want an interface called storage 1, and we're going to put that on this first interface. And the VLAN tag for this is going to be, what we're going to call this? We're going to call it 250, I think I called it. Let me just double check. So in the background, I've already configured a bunch of VLANs. 150, I nearly made a mistake. 150 and 151. So I've already configured a bunch of VLANs across my network hardware for this. And so we're just going to be utilizing those here. So we're going to call VLAN 150. Save. Okay, so we're gonna, the interface name needs to be VLAN 150. Save. Silly me. And then we're going to do the same again for the other interface. So we're going to have VLAN 151, and I'm going to put that on this interface 151, and we're going to call this, actually we can put a nice description in there, storage 2 and storage 1, just so we know in future what it is. storage 1. Okay, great. Okay, so there we go. We got the VLANs configured. So let's just take a look at our network summary again. We're still not seeing that there. That's because we haven't got the interfaces. Yeah, okay, so the interfaces aren't configured here. So again, what we're gonna want to do is just plumb some config into this. So we're not going to use DHCP. I'm actually going to use, there's no DHCP on this network. So what I'm actually going to do is configure some addresses like this. So because we're across two different VLANs, and what I want to do is enable iSCSI multipathing a bit further down the line. So I'm actually going to create two subnets. We're going to create 192.168.250 and 251, and that means that when we come to do our multipathing, it'll work a little bit nicer because we'll have two different physical connections, two VLANs, two subnets, kind of separating the traffic, and so it will actually go down each interface instead of just whatever comes out first. So there we go. In fact, probably want to set the MTU as well. So actually, I'm going to set these settings here up, MTU 9000. We'll set those like that. There's some additional settings that I have set on these before in the past. When it comes to things like enabling TSO, because you want to have, so the network cards I've got in here, the Chelseo T420s or something like that, and they support hardware offload of iSCSI. Unfortunately, it doesn't seem to be working in kind of HBA mode in FreeNAS. You've not seen me load a driver, it's just using the standard 10 gig driver. So I'm not too concerned about that. I just want to squirt 10 gig traffic down it. So our second VLAN, we're going to do the same thing, 251, and I'm going to give it the same IP number. So we're going to put it in number 2, and that's going to be a /24. And I'm going to use the same options here. So up to make sure the interface comes up, MTU 9000 to make sure that we're using 9K MTU. Your mileage may vary with this. If you're worried at all about using a 9K MTU, you're not sure about what 9K MTU is on your switches or on your other devices, don't bother with it. It can be a bit more of a headache than it's worth. You don't get a huge amount of extra gain for it. I'm just setting 9K MTU out of habit. Okay, so we got our network configured now. I'm not going to configure anything for IPMI. I don't think I need to at the moment. I don't think it really gives us anything. Actually, I'll tell you what, let's configure it because I don't know what it's actually going to give us. So that's my IPMI password. There we go. I'm not sure why it's asking me to set an IP address. That doesn't feel right. So I'm not going to set that because that doesn't feel right. I expected this to maybe talk to the IPMI board on the box or something. Link aggregations, we're not going to configure any of these. What you could do if you wanted was to configure both of the 10 gig links into be a single 20 gig link. It's not quite as straightforward as that. It doesn't necessarily mean that you get 20 gig of throughput on a single connection. It would across multiple connections depending where the traffic originates and all that kind of stuff. There's some hashing mechanisms that happen to figure out where traffic, which interface the traffic should be squirted down. Okay, so network summary is looking a bit healthier now. We've got our two VLANs. We've got a default route, we've got our name servers, and we've got our management address. So I'm quite happy with that. So next thing we're going to want to do is turn on some services. So how are we going to actually use this thing? So this, out of the box, FreeNAS has a bunch of stuff. Everything's switched off except for Smart, so it's quite lightweight. In our case, we're going to be enabling iSCSI. So I'll just tick that on. We want it to start automatically. We're going to enable net data because that gives us some nice graphing as well. So we want that to start automatically. We're going to enable NFS because we're going to want some kind of cold storage type things going on. And I am tempted to enable S3 because I'm going to have some applications which are going to be able to interact with S3. But I'm not going to enable that just yet. AFP actually is quite nice if you want to start doing things like time machine backups, which I will do. I'm not going to do it just yet, so we'll leave it as is for now. So we've enabled iSCSI for our block storage. We've enabled NFS for our file storage. We haven't enabled the object storage. We're not going to enable things like SMB. I am going to enable SSH actually. Just because it's quite handy if you want to log into the box and see what's going on, especially if the front end kind of hangs or anything like that. I have had it in the past where I've been hammering the box so hard that I've needed to have a look at what's going on. Right, let's have a quick look at net data here. So net data is really cool. It gives you some really nice graphs about what's going on with your box. Obviously, there's not a lot going on here because we haven't got anything configured, but you can kind of see what it's doing for you. So you're getting how much CPU and RAM and how busy your disks are and all that kind of stuff, how busy your ZFS pools are and all that kind of good stuff. So it's worth enabling this just for a bit of a kind of overview on what's going on with your box, with your machine. So if we go back to FreeNAS, and now we're going to get to the good bit. We're going to start configuring some storage. So first pool we're going to configure is create pool. Right, so the first pool we're going to create is going to be called Bronze Pool 1. And our bronze pool is going to be formed purely of these slow spinny disks. So I'm going to grab all of these spinny disks and stick them into a single VDEV. Now, depending on your choice of VDEV and depending on what your availability and performance requirements are, you're going to want to choose different mechanisms here. So we kind of alluded on a previous video or maybe earlier this video that for a virtual machine type workload, stripes or mirrors is the way to go. Probably mirrors, so you've got a bit of redundancy there. And we're going to configure the SSDs in this mirror format purely for performance. You lose half your capacity, but you kind of incrementally increase your performance. Not quite incrementally, but you get the idea. You end up with the best kind of performance profile for virtual machines. In this case, because this is going to be slowy, coldy type storage, I'm not going to use RAID Z2. If I had more disks, I probably would. I'm going to go for RAID Z, and the difference between that, if you can see here, is the usage of a single disk. So RAID Z1, you can lose a disk and not have to worry about your pool going away or losing all your data. RAID Z2, you can actually lose 2. So it's all about how the parity is spread and how the parity is calculated in order to give you the extra resilience. Obviously, if you care more about resilience, you're going to want to go for, and if the data is anything important, you're going to want to go for RAID Z2, RAID Z3, especially if you've got a large pool of disks. But for me, I'm probably not going to care too much about what's being stored on this, so I'm going to go RAID Z, and I'll take my chances. As well, what I'll end up doing is backing this stuff up anyway, either off-site or to another box, just so that I've got a bit of redundancy. So going anything more than RAID Z isn't too much of a concern for me. It's worth noting as well, though, that when you get over a certain size of disk, you start getting into kind of probabilities of failures during a rebuild. So there's some real good papers out there on ZFS, some real good websites that people have shared information and their experiences. I highly recommend you doing some research before selecting your disk types. In the past, I've made bad choices with the disks. So I had a box which had 36 bits of rust in it, and I selected RAID Z, I think, for the pools, and created effectively, what would it be? Math not so good for me. It was like 7 pools of RAID Zs or something like that, and the VM performance wasn't great. I ended up moving all the data off and recreating it as mirrors, which gave a bit better performance. So just bear that in mind as you're going. Anyway, back to this. So we're not going to add any cache, and we're not going to add any log disks at this point with for this set of disks. We may want to in the future, so it would be beneficial for us to stick an NVMe disk in front of this, just for write performance or read performance, then depending on what type of profile we're after. But for right now, I don't really care about the performance, and actually I'd like to compare before log and after log. You can add the cache drives and the log drives later anyway, so it's not a big deal. It's actually quite a nice feature of ZFS to be able to do that. So if we go ahead now and we create this, what it'll do is it'll go through in the background for us and it'll wipe all these disks. During boot, it was complaining that the partitions were already configured and stuff was on the disks, and oh my gosh, we need to do something about it. So it took care of that, and as you can see, we've now got a pool that we can use. So we're going to do the same thing again now. We're going to create a new pool, and this time we're going to chuck our SSDs at it. So we're going to call this gold pool pool 01. I'm not going to encrypt it, not at this point anyway. We can suggest a layout, and what it's going to do is, well, that's great. It's going to just stick an NVD in there. That's the NVMe drive, which I don't want to do, but I am going to select all of the disks, go to the end here, and then unselect the NVMe. And actually, no, that's not going to do what I want. Okay, so we're going to select 2 disks, bosh. That's going to be a mirror, so it means that we're getting that. Alternatively, you could start striping things and then you get more disk, more space, more performance, but no resiliency at all. So if you lose any single disk, you've lost all your data. So go with mirrors. Practice safe data. Right, okay, so let's go on to the next lot. Do the same again. That'll create a mirror for us. And the same again. And there we go. And there's all of our disks in mirrored VDEVs. What will happen is when these disks are being used, ZFS stripes the writes across the VDEVs, so your performance is effectively the slowest disk in any VDEV. So for reads, 2 devices in each mirror are going to be able to deal with a read, and for writes, they're going to get spread across the VDEVs. So it's quite nice. Okay, and there we go. That's our pool configured. So we now got two pools here. We got a bronze pool, which is spinny rust, and a nice fast gold tier. Okay, so we've got the pools configured, but how do we use them? So in order to do that, we need to create a ZFOL. ZFOL gives you basically block storage, so I'm going to cut and gives you kind of a container to put things in. So if you've got quotas or you want to limit things, you can do it with this. It's kind of a logical grouping, I guess. So this ZFOL, we're going to call this gold block. Actually, yeah, it was the gold pool. Gold block 1. We're going to create this 2 terabytes. Something to watch out for with ZFS as well. You don't really want to fill your pools up more than 80%, because as soon as you do, you're going to start incurring performance penalties. So just watch out for that. So in this case, I'm going to leave the synchronous writes just in these settings here. We'll leave them as standard. It shouldn't be too big of a deal for this pool. Compression, we're going to want to leave to LZs for, and dedupe we're going to turn on, but I'm going to turn that on at a higher level. You can specify sparse pools, which is your thin provisioning. I tend not to, purely because of the performance penalties. On the first write, it does take a bit longer. Block size, what should we set block size to? Block size is set, so we'll inherit that. We want it to be whatever it wants it to be. Okay, there we go. And so in this yeah, we'll leave that like that. Okay, so there's our storage. We're going to do the same thing again for the bronze pool. So if we add a Z file, and we're going to call this bronze, can't remember what I called the other one, bronze store 01. We're going to make this one 5 terabytes. So we're not going to want compression. Compression we do want, dedupe not so much. Dedupe has a memory penalty as well. We'll leave sync and all that kind of good stuff, and we'll just let it figure out the rest. And cool. Okay, so there we go. We've got a gold pool and a bronze pool configured. Block. Never mind. Maybe I can rename it so it has a. No, I can't rename it. Never mind. That can stay as it is. Okay, so for our gold pool, we just said that we're going to enable. Where are we? We're going to enable dedupe. Okay, so this dedupe adds some memory and some CPU overheads, just like compression does. But I'm alright with that. This is a pretty beefy box, so it shouldn't have any issues, especially with the amount of traffic that I'm planning on throwing at it. It should be absolutely fine. So now what the next thing that we need to do is make our block storage available using iSCSI. So in sharing and under block iSCSI, what we're going to need to do now is configure some portals. So if we call this one oVirt and discovery, we're going to create chap, and we're going to create, we're going to want to limit the IP addresses this auth group works, this portal listens on. You don't want it to listen on all IP addresses, because otherwise when you start doing multipathing, auto discovered multipathing, it'll start picking them up on your management network, and as it's a bit slower that network, you don't really want things to be routed down that way. So it's complaining here that the auth group isn't set, and that's because I haven't created any yet. So if I just configure that, so we've got the portal configured without any authentication at the moment. And if we go to authorized access, yeah, there we go. And group ID 1, user, oVirt, and secret can be secret, doesn't really matter. Peer user, we don't care about this because we won't use mutual chat, we'll just use single direction chat. Okay, so the password must be between 12 and 16. Okay. There we go. Fiverr says I forget what that is. Okay, so if we go back to the portal now, and we can go ahead and configure, we're going to configure chap, and then we're going to configure group discovery auth group 1, which is the group that we've just created. Okay, so now we need an initiator. So in this case, because I'm feeling lazy, we're just going to say all host names can access. Actually, no, we're not. We're going to do it properly. We're going to configure 250.0 /24 and 192.168.251.0/24, and that should restrict this. If you look here, network addresses, it can use the initiator. Actually, it's space delimited. There we go. Allow storage VLANs. There we go. So all of our initiators will have that restriction. So you've got to be on the storage network to access it. Right, let's start thinking about targets. So in order for, so we've got the actual thing that says, hey, I'm iSCSI, I'm serving some stuff. That's all set up now. We've got a username and password set up so that servers can now authenticate. But now we need to actually present some block storage. And the way we do that is by creating a target. So our first target here, if we call this gold block 01, I mean, if you wanted to, you could put target in front of it like that, just so that you know that's what it is. Portal group, we're going to attach it to the oVirt portal we've just created, and we're going to put it onto this initiator group, and we're going to tell it it's chap, and we're going to provide auth group 1. And so that means that anything trying to access or get a list of LUNs that are available, they're going to have to authenticate. Okay, so it doesn't like that, so we'll do that. Okay, and so now we'll create an extent. So we created a target, which is a list, set of block LUNs. Now we'll create the extent. What we'll call this, I don't know, gold block 01 ext device. So this is going to be a device because it's a physical block we've got. So we're going to expose this gold block here. We're going to leave the logical block size to be 512. I know that oVirt doesn't support anything bigger. TPC, I'll leave that as default. Zen initiator, we don't need to set that. We know we're on SSDs. Okay, so we can create that. And then I'm going to do the same again for bronze. So bronze block 01. Actually, ext bronze block 01 device, and the device is that, and 512 again. So this is 5,400. So I'm going to set the LUNs. Actually, no, I'm not, because what will happen is if you set this to anything other than SSD, things try to dedupe, which has some performance implications. So let's leave that as it is for now. Okay, so now we can associate the targets with the extents, and this is what makes things actually start showing up. So on the gold block 01 target that I've just created and realized that that's probably not the right name for a target, so I'm actually going to go and recreate that. Edit, we're not going to call it target gold block 01, we're going to call it oVirt data stores. There we go. Now we can associate them correctly. So if we go here, oVirt data stores, LUN ID 1. So LUN 1 is going to be our gold storage. We'll create that. And LUN 10. 10. No, I'll do it in 2. In oVirt data stores is going to be our bronze storage. And there we are. We've presented some block storage to our VMs. So now when we come to set up oVirt in the next video, we've got our storage in place. We've got all the bits we need to be able to access it. We've got the credentials and all that kind of jazz, all the networking all configured. So it should be ready to go. All right, well, thanks very much for watching. Hopefully this has been interesting. If you like it, like, subscribe, do all that YouTubey jazz. If you didn't, leave me a comment. Please let me know how I can improve. Other than that, have a great day. Bye-bye.